A brain implant enabled communication with a completely paralyzed person. In its final stages, amyotrophic lateral sclerosis, ALS, can lead to extreme isolation. As the disease progresses, it leads to loss of muscle control, including the muscles involved in communication, making communication impossible. But with the help of an implanted device that reads signals from the brain, a person confined to their own body can once again communicate with the world. Patients with amyotrophic lateral sclerosis, ALS, gradually lose muscle control. Motor function deteriorates, and in later stages, complete paralysis and death occur due to respiratory muscle failure. Death typically occurs within 3 to 5 years of the disease, but there are examples such as the renowned astrophysicist Stephen Hawking, who battled the disease for over 50 years. The disease typically does not affect a person's intellectual abilities, meaning that in later stages, the patient cannot move a single muscle but remains conscious and aware, confined to their own body. As the disease progresses, the ability to speak declines. For years, Hawking used a speech synthesizer to communicate with the outside world, entering his own thoughts via a virtual keyboard. Further progression of the disease leads to locked-in syndrome, in which consciousness remains, but muscle movement is limited, at best, to the eyes and eyelids. Locked-in syndrome can also have other causes. Difficulty communicating is well captured in the film based on Jean-Dominique Bauby's autobiography, The Diving Bell and the Butterfly, in which the protagonist, after a stroke, suffered locked-in syndrome and could only move his left eyelid. Although this was extremely demanding and took a long time, the protagonist retained the ability to communicate. Scientists are trying to help people with locked-in syndrome. In Nature Communications, Dr. Jonas Zimmerman of the Weiss Center and his colleagues reported their success in translating the brainwaves of a patient with ALS locked in his own body into text. ALS destroys the nerves that control movement, and most patients die within 5 years of diagnosis. When a person with ALS can no longer speak, their only option is to use an eye-tracking camera to select letters on a screen and thus communicate with the world. Later in the disease, patients can only answer yes or no questions with subtle movements of their eyes or eyelids. In 2018, the 36-year-old ALS patient began working with a research team at the University of Tübingen. At that time, he could still move his eyes. He expressed a desire for an invasive implant to attempt to maintain communication with his family, including his young son. His wife and sister gave written consent for the surgery. During the surgery, researchers inserted tiny 3.2 mm wide electrodes that detected neural signals into the part of the brain that controls movement. Then, in a painstaking process lasting several months, the man learned to control brain activity by commanding his body to move his hands, feet, head, or eyes. Although his body didn't respond, the implant recorded brain activity. The researchers opted for a strategy in which the patient attempts to modify brain signals while obtaining real-time measurement of their success. The exercise involved controlling sounds. The patient had to match the frequency of their brain waves to a specific pitch by commanding their body to move. It took the patient 12 days to learn. After that, they could tune the sound to a target pitch. Matching and maintaining the frequency at a specific level for 500 milliseconds allowed them to elicit a positive or negative response from the system. By maintaining high or low sounds, the patient could then indicate yes or no. The researchers then used a program that reads the letters of the alphabet aloud. The man used his brain waves to select the appropriate letters while constructing a word. This process is slow, about 1 letter per minute, but it allowed the patient to regain the ability to communicate with those around him. After about 3 weeks of working with the system, the patient uttered a comprehensible sentence, a request to caregivers to change his position. Since then, he has written dozens of sentences. The process is tedious, which means the patient doesn't express complex tirades, only simple messages like, "Goulash soup and split pea soup," "I'd like to listen to Tool's album loudly," "I love my cool son." These studies indicate that it's possible to maintain communication with people suffering from locked-in syndrome by tailoring a brain-computer interface to the individual. Our research shows that it's possible to write sentences using your brain, even if you're completely paralyzed, even without the ability to move your eyes or other muscles that could communicate, said Niels Burbaumer of the University of Tübingen in Germany. Unfortunately, the technology used in this brain-computer interface is still very expensive and requires significant time to fine-tune for a specific patient. Furthermore, caregivers must be trained to configure the system and verify the patient's responses so that the person can effectively communicate through the brain implant. A vast subsurface ocean of liquid water has been discovered on Mars. New research on Mars has revealed that a vast ocean of liquid water exists deep beneath the planet's surface. The findings come from a new analysis of data collected by the Mars InSight spacecraft, which spent 4 years listening for seismic events on the red planet. On November 26, 2018, the Mars InSight lander touched down on Mars in a shallow crater called Homestead Hollow in the Elysium Planitia region. The mission's primary goal was to gather information about the red planet's internal structure and its current geological activity, all in an effort to understand how Earth's neighboring planet was formed. Scientific instruments aboard the lander conducted hundreds of geophysical surveys. These included the ultra-precise SEIS seismic experiment for interior structure, seismometer, and the HP3 Heat Flow and Physical Properties Package heat probe, also known as the MOLE, which was designed and constructed in collaboration with researchers from the Polish Academy of Sciences, among others. It turned out that in the data collected by SEIS, geophysicists had found evidence of a large, subsurface reservoir of liquid water. Scientists estimated that this reservoir contained enough water to cover the entire planet with an ocean 1 to 2 kilometers deep. The results and description of the research were published in the Proceedings of the National Academy of Sciences. Many studies conducted in recent years have demonstrated the presence of water on Mars. The planet was once warm and humid. Rivers and lakes existed there, and traces of them are visible in the terrain and other geological structures. Researchers have determined that water deposited as ice is found at the poles, beneath the surface, but ice can also be found in other areas on the red planet. Now it turns out there's much more water on Mars. Data collected by the Mars InSight mission suggests the existence of a vast ocean of liquid water beneath the planet's surface. However, it's out of reach. Nevertheless, it's an important piece of Mars's history and could lead to a better understanding of the evolution of the red planet's climate, surface, and interior. A vast underground reservoir, discovered using seismic data collected by the InSight lander, contains enough liquid to cover the entire planet. However, it is too deep to access. It lies in a layer of fractured rock, lying between 11.5 and 20 kilometers beneath the Martian surface. Even on Earth, drilling a hole to this depth would be a challenge. The world's deepest borehole, the Kola Superdeep Borehole, reaches a depth of just over 12 kilometers. In the ancient past, billions of years ago, Mars looked very different from today. Evidence still found on its surface indicates that it once held vast seas, rivers, and lakes. The question is, where did all this water go? Until now, it was thought to have escaped into space with Mars' atmosphere. But new research indicates that much of it may have remained on the red planet. The Mars InSight lander sat on the dusty surface of the red planet for 4 years listening. During that time, it recorded over 1,319 seismic events. By measuring the speed at which seismic waves travel, scientists determined what material they were most likely traveling through. These are essentially the same techniques we use to search for water, oil, and gas on Earth, explained Professor Michael Manga of the University of California, Berkeley, co-author of the study. The InSight mission far exceeded my expectations. By analyzing all the seismic data collected by InSight, scientists determined the thickness of the crust, the composition of the core, its depth, and even obtained some information about the temperature within the Martian mantle, he added. Waves generated by seismic activity within the planet, or those from meteorite impacts, vary depending on the density and composition of the material through which they travel. Scientists who analyze data based on the behavior of seismic waves can draw conclusions about what material this might be. After applying models used to map underground oil and gas deposits to the Mars data, they concluded that the seismic data from the InSight mission best matched layers of fractured igneous rock saturated with liquid water. Establishing that there is a large reservoir of liquid water provides some insight into what the climate was, or might be like there. And water is essential for life as we know it. I see no reason why an underground reservoir couldn't be a habitable environment. On Earth, deep mines are habitats for life. The ocean floor is habitats for life. We haven't found any evidence of life on Mars, but at least we've identified a place that should be able to support it, Magna noted. Manga also emphasized that a wealth of evidence, including river channels, deltas, and sediments, as well as water-altered rocks, supports the hypothesis that water once flowed on the red planet's surface. However, this period ended more than 3 billion years ago, after Mars lost its atmosphere. The new findings indicate that much of the water did not escape into space, but percolated toward the planet's interior.